Hey, Vsauce, Michael here, and what do you say we get out of here to space and into an orbit? That way we could just float around and be free from the influence of gravity. Except not really. Astronauts orbiting around the Earth experience pretty much the same gravitational pull that you and I are feeling right now. The major difference is that those astronauts are falling constantly towards Earth, but their angular velocity is so large that they're falling just as fast as Earth curves away from them. Now, of course, this is nothing new. Tun's canon hasn't already taught us.
Gravity makes stuff fall, and in particular, Newton realized that it makes objects accelerate towards the Earth the same amount independently of how fast they're moving horizontally. That's called relativity. And of course, orbiting is just falling, but falling where you move horizontally fast enough that the Earth falls away faster. In order to successfully fall and miss the Earth, unless you dug a tunnel, you'd need to be traveling at almost 17,000 miles per hour, or 8 kilometers every second. So you'd probably incinerate from friction with the air well before you had a chance to enjoy the trip. Of course,
Newton's thought experiment involved the Earth, but on something smaller like the Moon, the cannon wouldn't have to throw its projectile nearly as fast for it to complete an orbit. In fact, if you had a powerful enough gun on the Moon, and you fired that gun at the horizon and then waited a little bit, you could get hit in the back of the head by the same bullet. Henry calculated that the bullet would have to travel about 1,600 meters per second, which is exactly how fast the Paris gun fires. Now that's a powerful gun, it's no squirt gun. But if you had a squirt gun out there in space and you fired a stream of water at the sun, how much water would it take to put out the sun? I mean, in general, putting water on something hot would cause that something hot to lose some heat, especially since the water will be frozen because it's out there in space. But here's the issue. The sun is not a big ball of hydrogen on fire. Instead, the sun is powered by fusion.
Fusion of hydrogen nuclei, which is kind of like the chemical bonds between the hydrogen and oxygen that make up water, except on a much smaller and much more powerful scale. Now, before I get tackled by nuclear physicists from one side and chemists from the other, let me explain. A bond of any sort, whether between planets, molecules, atoms, nuclei, or quarks, is just a happenstance where two or more particles together have a lower total energy than when they were apart. Like if you get married and your taxes go down. So when you form a bond, that extra energy that the two solitary particles had is released. And because of a little relation we call E equals mc squared, this actually means that the mass of the pair goes down a little bit too. For example, every fusion reaction turns a little bit of hydrogenous mass into light. Sunlight, for example, amounts to a loss of 100 quadrillion kilograms each year. That's the equivalent of a medium-sized asteroid. But stars have a lot of mass.
And the more massive a star is, the hotter it burns.
And adding a bunch of water to the sun would only cause it to be more massive, so it would burn brighter, not go out. Of course, it would also burn faster, which means that its life would be shorter. For instance, if you were to add 20 solar masses of water to the sun, you would decrease its life expectancy from the current 5 billion years to only a few hundred million more years. But there's a faster way to put out the sun. Take that water or whatever material you want and shoot it into the sun in a way that causes everything to get spread out and scattered so that there's no longer the critical density needed for fusion to occur. Now, no matter which avenue of putting out the sun you pick, both would be a disaster. Literally. Disaster. From dis meaning against and aster meaning star. You would have literally turned our own star against us. If you were somehow able to avoid that disaster by magically appearing in intergalactic space, here's a fun experiment to try. Take out your gun and fire a bullet. That bullet will be forever alone.
That's because the universe is expanding, and if you were a few megaparsecs away from the nearest galactic cluster, on average those galaxies would be 200 kilometers farther away from you every passing second. In space terms, 200 kilometers a second is pretty slow. It's barely as fast as the solar system orbits the center of the Milky Way, and stars closer to the center of the galaxy can orbit 10 times faster. But a measly bullet travels only a few kilometers every second, and would have no chance of reaching the receding galaxies ever.
It makes you realize how tiny we are compared to the scale of the universe. But it also makes you realize how close together we all are here on Earth. Of course, to get from one side of the Earth to the other, you have to fly over half the sphere.
So what if instead there were a tunnel through the Earth? Let's jump over to my channel, Minute Physics, to see what happens. Click here, and I'll see you on the other side. Oh, and as always, thanks for watching.